Okay, with these two problems here, we're asked to construct two triangles and then find the missing sides and angles. For these particular problems that are non-right triangles, it's typical to use what's called the law of sines. This set of equations are going to help us determine what those missing angles and sides are. Now, here, as you can see, I've written two variations, the one on the left and then the one on the right. Now, when do you use which one? Well, my recommendation is this. It's always best practice to keep the missing variable that you're trying to find on top if you're dealing with fractions. This will simplify the amount of math you have to do in order to find that actual value. Now, just keep note that you can use either one of these versions, but if you use the right one, again, it'll save you some time. The other one will force you to do a little bit more math than you might want to. So let's start off with exercise 9. It might actually bleed over to number 10, but we'll erase it at the end so that we can do one at a time. Now, first step that you want to do in order to achieve finding all the missing angles and sides is to construct a triangle and then label it with all the parts that you have and don't have. So if you look at what I wrote, angle A will always be opposite to side, which is little a. All the sides are always denoted in most cases by a lowercase and all the angles by an uppercase. I just noticed that I didn't write this angle here. That was given. Now the question is, what do we solve for first? Do we solve for angle B, angle C, or side B? It's best to always solve for the angle or side for which you already have some information for. So let's look at this. Angle A and little a is already given, so we're going to use that. And then we're also going to use angle C and little c. The reason why we don't want to use B at all is because we actually have no information for it at all. So let's begin by writing out the law of sine and using the numbers that are given in this particular problem. So since I want to try to find angle C, I'm going to go ahead and start that. So sine C goes on top, that means little c goes on bottom, and that equals what we already have, which is sine A over little a. Now just to do some simple math here, that is going to be times 21. Now in order to actually solve for angle C, we're going to need to apply the inverse function. Okay, you can already have computed this and actually have entered a decimal, but we're going to save some time and not do that. So the answer here is going to be that angle C is approximately 53.8. Okay. Now, the interesting part about this is that there's a possibility of there being two solutions, one solution, or no solution. We're going to use the idea that for any given triangle, its interior angles always add up to 180. So this is what we're actually going to use here in order to determine, to see if this is actually a possible answer. All right. So in order to make this happen, we want to go ahead and add this to the angle that was already given and see if those two angles added together are actually less than 180. And if you add this up, it in fact is. So what does that say? That means that 53.8 degrees is a possible value for angle C. The reason being is because if it at any point exceeded 180, that means that just having those two angles would have given you what three angles should have added up to. So if it exceeds 180, that means in this particular case that B couldn't have even been an angle, but it can be because we just checked it. So we're good here. Now, the goal here is to see if there's another possible angle, a solution to what C could potentially be. In order to do this, you just take 180 and subtract it to the current answer that you just obtained. That's 53.8 degrees. So if we do this correctly, then that should be 126.2 degrees. Now the question is, I'm going to go ahead and box it, but then verify if this in fact can be an actual answer. So in order to do this, I take the 126 degrees and add it to the 25 and ask myself, is that 180? Now for this particular problem, or this part, I will add it on my calculator just to ensure that it is under 180. And it is. It's 151.2. That means that we have another triangle that is a possible setup for what we have here. So we're going to draw the original triangle like we did, with the exception now that we're going to have a different solution for angle C. So A, B, and C are going to be as follows. And that's 25. And here we're going to add the new angle that C is 126.2. Meanwhile, for this other one, we're going to put 53.8. Okay? So now for this number 9, there's actually two possible solutions here. Okay? And we've drawn these. Now, I've actually made a little boo-boo here that I've mentioned in class. And that is that we kind of don't want to use A, B, and C. It's kind of a little bit inappropriate. It's like bad math because we cannot, I explained that we cannot or don't want to use ABC since we already used it up here. And we can see that these are not the same triangle. So by setting them to ABC, it's like saying that they should be the same triangle, and clearly they're not. So we can quickly adjust this by just putting a little subscript of 1. Okay, in class I mentioned that this could have been DEF instead of ABC. But it's not a big deal, right? We want to get down the process, so don't worry about it. Okay, so let's find the remaining components. So here we can tell that we're missing B and angle B. And then on the top triangle, it's the same thing. We're missing angle B and little b. Okay, so we're going to use again the idea that any triangle, its angles must add up to 180 degrees. So that's the easiest part of this, right? So if you want to figure angle B out for this one, you add these two and you subtract it from 180. And in our case, we should probably end up with the following. (102) or 101.2 degrees. Okay, and for this bottom one, we should end up with 28.8 degrees. So again, the angle A, the B, and the C, once you have two angles, you can just add those angles that you have and subtract it from 180 to get the third angle. So we're done with the angles actually. That's the quickest part. Now we're going to need to apply another variation, right, or another iteration of the law of sines in order to obtain B1 and B. So with that being said, let's go ahead and do that. So at this point, you just want to go ahead for sure and start off at least with the top one being B, right? And then that's going to be over sine B, which is 101.2. And that equals, let's go ahead and grab any other side. I'm going to go ahead and get A. So 11 over sine 25. Okay, that's the top one. And this bottom one is going to be a similar situation in that we're going to want B1 on top, followed by sine B at the bottom. So that's, in this case, 28.8. Okay, equals, I'm going to grab just A again. So 11 over sine 25. Note that you could have used sine C as well. I just prefer using the smallest number if possible. Okay, so with that being said, to solve for B up here, we got 11 over sine 25, which is equal to, 11 over sine 25 times sine 101.2. And then on the bottom is going to be B1 is equal to 11 over sine 25 times sine 28.8. So for the top one, if we do the math correctly, we should end up with B being 25.5, about right. Now, if you're off a decimal point or two, you're fine. Now, if you ended up with 35 instead of 25, then we're going to have issues. When it comes to the sides, you don't really have to check it. They work out as is. So just so I don't have to scroll down much, I'll write the answer up here. B of 1. So for this other B, we should end up with 12.5. Cool. So this is what you should end up with. Pause the video if you want to process all this. But effectively, we're done with finding all the angles and all the parts of these two triangles. So I'm going to go ahead and erase this right now. So please pause it so that I can begin problem 10. So let's go ahead and at least make some space here. And now we're going to have this other triangle that we're going to do. And let's go ahead and label it. I would recommend you pausing the video and trying it for yourself. But let's go ahead and have the same sort of process that we did earlier. So we're going to have to look for not A, right? Because there's no information for A. So we're going to start by finding angle B. So sine B over little b, okay, is equal to sine C over little c. So if we do the math, this equals to, I'm like speed writing here. As I mentioned before, this is a little tedious, but it'll be okay. So with that being said, that's probably going to be approximately, and then we do the inverse of that. Okay. And then B is going to be approximately 26.1 degrees. Okay. So now we're at the point that we want to check this. Okay. So in this case, we're going to add the 26.1 to the angle that's already there. And we can tell just by looking at this, it's going to be somewhere around the 30s, 40s, probably 40s, 140s. So I feel like we should be fine, right? So with that being said, this is going to be less than 180, and this is a good answer, right? So what we're going to have is then this triangle will then become angle B with an angle measure of 26.1 degrees. And now, before we go any further, let's go ahead and check to see if there's another possible triangle. So with that being said, we take 180 and we subtract the 26.1. So 180 minus 26.1, and that leaves us at 153.9. Now, in order to see if this is going to work or not, we're going to have to add this 153.9 to what's already there, which is 114. And just by looking at that, that is way bigger than 180. So this, luckily for us, fails. So with that being said, there is no solution to, there is no second triangle. We just simply finished the one that we just started. So fortunately for us, we're almost there. We need to find little a. So let's quickly just hash it out, but we should be good for the most part. Actually, we also missing angle A. But if you, again, add 114 to 26.1 and subtract that from 180, then you should end up with around 39.9 degrees for angle A. And that's that. So let's go ahead and start with what we're missing. We're missing A, okay? And that's going to be over sine A, which is 39.9, equals And then choose again any other side you want because you have the rest of the information. I'm going to choose B because that's smaller. 13 over, sine B, which is 26.1. Okay. So with that being said, if we do the math, A is equal to 13 over sine 26.1 degrees times sine 39.9. And then we should get with A being approximately 19. And there you go. That's how you do it. Again, rewind, forward, whatever it is you need to do. And I hope that this helps.